Hey there, welcome back to the channel. My name is Chris, and today I want to go over a very simple circuit and some code that I like to add to a lot of my projects to make them easier to debug, and it also helps to add features in the future. So let's take a look at what I'm working on. I'm adding a feature here. This is an INA219 so that I can do some power measurement. And I'm going to do a video on that in the future, but what's more interesting, what I want to talk about today, is this little thing that I've put in up here. Really what I've got is I've got a pull-up resistor going to one of these lines, and it comes over to D05, so one of the inputs, and then the other one goes to ground. So basically what I've got is this. I've got this input on my microcontroller. It's pulled to 5 volts through a 10K resistor, and that goes to one pin. This pin is right here. And then I've got the other pin just tied to ground here. And right now I've got a wire connecting the two. But I can pull that out and put in a push button to allow me to open and close that. So you might ask, okay, well, what's the purpose of this? What do I use it for? Well, first, I can use it when I'm debugging to change the behavior or have it do something at startup. Maybe change the state of how something works. Another option is I can use this to change features as I move forward with the product. So I can have it open for one feature set and closed for another feature set. Let's go take a look at this in practice though, so it'll make a little bit more sense. Let's say in my solution, I want to have the option at boot time to have a feature enabled. Maybe it's a debug feature, maybe I change screens, maybe it's an admin feature, whatever. I have some feature that I want to be able to select physically at startup. What I've got here is I've got these options. So let's say we've used the button that I just showed in that hardware, and when it boots up, it looks to see if the button is down, and then we're going to say we want the user to hold the button for a certain period of time. So either the button was detected or not, and then after a period of time, the option is either not selected, they either didn't hold the button at all or released it before the time is up, or the option has been selected. So that's what this state enumeration is for. And I've added to my platform settings a couple of items. I've got the pin, which is the option is connected to. So what pin is this IO connected to, or this button? And then I have this option selected action. So it's an action to take when this option is selected. And it's a little confusing right now, but let's go take a look at how it's used. It'll be real clear. So when the application starts up, we're going to enter initialize. And first we're going to set up our settings. For this, the F7, we have the pin D05 is connected to this circuit. And then the option selected action I have is just an action down here. We've got an RGB LED, the onboard LED. And so depending on what the state is, it's just going to do some action. It's going to set the color to yellow if it sees the button at startup. And then if it is not selected, it's going to turn the red LED on for 2 seconds. And if the option is selected, it's going to start blinking the green LED and just leave it blinking forever so that we know we're in that optional state selection. So let's go take a look at how this is actually used in my application now. If you recall how this application works, basically in the initialize for the specific platform, we create this app engine and we pass in the I2C bus and the settings. And that is what is used for talking to the accelerometer and the display and the other hardware on this. This app engine, what I've added is we're just going to check to see if the startup option is selected. Everything else is the same as previous videos on this. So the accelerometer and the display, as well as some buttons for left and right. But if we come down and take a look at this is option selected, it's really, really simple. What we've done is we're creating a digital input port on that pin. I have an external pull-up on this. The reason I went with an external pull-up instead of an internal is so that it can work on both the Raspberry Pi as well as the F7. And if you're using a Raspberry Pi that has an OS that doesn't support turning on the internal pull-ups, it will still work. So what it does is it then checks to see, is the state low? So right now, we have it hooked to high, so it will always be high unless we're pushing that button. So if we're pushing the button, it's going to be low. So if it's low, we know that they have at least started with the button down. And so we're going to say, hey, the button has been detected, and this just invokes that action, which you recall turns the LED yellow on the F7. And then we're going to wait 2 seconds. So we want the user to hold that button down for 2 seconds in order to enable this feature. After 2 seconds, if the button is still down, so that the signal is still low, we're going to change to this option selected. Otherwise, we're going to do option not selected. And if the button was, or if the port was high, so the button was not pressed to begin with, we're just going to go direct to option not selected. So now if I power this up and I don't have the button pressed, we'll see it starts out blue as the bootloader is going. Then it's going to shut off and the application will be running at that point, and it will give us, should be a red LED because the option is not selected. There we go. Now, if we reset it, and I've got the button, I'm going to press it. I could start pressing it now, but we know it's not going to start checking the state until after the bootloader finishes. So once the bootloader is done, I'll press the button. We get yellow. I release it before it's done, and we go back to not selected. Now, if I reset it again, we can go to the third state. We'll again let the bootloader run. I can press and hold. It sees that I'm holding it, and it said I held it for 2 seconds. So now we are in this option state where it continually blinks the green LED. So the idea here is you could take a button and put it on maybe the outside of your enclosure or inside under a cover, something along those lines, and it can give you a feature. Let's say you have a field debugging thing that you want to be able to enable, or some sort of an administrator mode, even a hard reset to go back to a known configuration, something along those lines. You can use a push button for that. Maybe you have a feature that you want to enable and just leave it on. You can use just a jumper. Right now this is female, but you could have 2 male pins and put a jumper on it. And I can go like this, and now it will always be in that state when it boots up. So I can change the behavior of my system using code that's already there without having to change like a configuration file. Configuration files are a pain because you have to have a text editor to change the config. Then you have to have a way to push the config to the device. This way, I'm really changing a configuration by just swapping something physically. This requires a single input on the device to be available. Most of the time, you'll have at least one available after you've done all of your other circuitry. So adding something like this is really simple. It gives you some extensibility of your platform. It adds the ability to do some debugging things that are challenging to do, especially in the field. And really, it consumes a single I/O. Most of the time, I've got at least one I/O left over that isn't being used by the solution. So I usually add something along these lines to make my life simpler. That's all I've got for today. Thanks for watching.